In our last video we've got an introduction to data compression. Now we come up to an important concept of entropy. Entropy shows at the end the average information content of a symbol. So, each symbol has its probability. This probability refers to a number of cases where we face our symbol in a sequence. For example, in this sequence, A's will be faced twice as much as B's and C's, because probability of A is 1/2 and probability of B is 1/4. So it will be in a sequence of 8 symbols, A is every second symbol, or 1/2 of symbols will be A. And let's actually look at the formula of the entropy. Here we have probability of a symbol multiplied by second logarithm of probability of the symbol once again. And at the end we have to use minus here. And to calculate the entropy of the given sequence for these symbols, we have to do the following: 1/2 multiplied by log 2 1/2 plus 1/4 multiplied by log 2 1/4. 2/8 are actually also can be represented as 1/4, right? Yes. And then at the end we will produce some number minus something. Minus is here because after calculating these numbers we also get some minus number, thus they will be eliminated. Minuses will be eliminated. I didn't calculate it, but I think it will be something around, let's say it will be something around 1.5 or 0.5. It's no matter now. What's matter it's that this number at the end will represent how much bits on average each symbol contains, and when encoding something, this is the absolute limit. You can never go below this limit when you encode something. It means that no matter which encoding scheme or function you use, you can never get less than this number at the end, because entropy is an absolute mathematical limitation for this. Now we address one very important concept of uniquely and not uniquely decodability of our code. So to understand that, we have to first understand what is prefix and what is dangling, suffix in our code words. Let's say we have these codes, and we can see that 0, 1 is also here and here, right? So it means that 0, 1 is a prefix of 0, 1, 0, 1. And we can obviously also see that 1, 1 is prefix for 1, 1, 0 is a prefix. It means that first symbols from 1, 1 are the same like here. Actually, the whole code word 1, 1 is a starting, let's say, letters of another code word. That means that it is a prefix. And what is left here in this example from 0 is left. 0 is a dangling suffix. Dangling suffix, it is what's left after we find our prefix and separate them. Prefix from what is left. Prefix-free codes are uniquely decodable. It means there's only one way to decode prefix-free code. Let's see here. Once again, what is prefix-free? Prefix-free means that there is no symbols in our sequence which are at the same time starting letters from another symbol. I'll give one more example of not prefix-free code. Once again, the whole symbol, in this case 1, 1 and 0, are starting symbols, starting letters in another code word symbols from our sequence. And that doesn't necessarily mean actually that this code is not uniquely decodable. But what I want to mention, prefix-free codes are always uniquely decodable. But if they're not prefix-free, it doesn't mean they're not uniquely decodable. In the next video I will show you the algorithm which will in 100% cases show you whether your code alphabet can be uniquely or not uniquely decodable.